The modern green revolution, the smartphone in your pocket, the high-speed rail networks, and the medical imaging devices in your local hospital all run on a hidden, invisible engine. They rely on a specific family of 17 elusive elements hidden deep within the Earth's crust. They are the rare earth elements. And while they might be scattered across the globe, the story of how they are actually extracted, separated, and transformed into the backbone of 21st century technology belongs almost entirely to one country. In 1992, Chinese leader Deng Xiaoping made a famous observation during a tour of southern China. He said, "The Middle East has oil. China has rare earths." It was a statement of profound geological fact, but more importantly, it was a blueprint for the future. It was the starting gun for a multi-decade industrial master plan. Today, China doesn't just mine these elements. They have mastered the incredibly complex science of refining them and turning them into advanced technological components. Today, we are going to look past the daily news headlines and dig deep into the engineering marvels, the scientific breakthroughs, and the unparalleled industrial scale that allowed China to build the world's most advanced, rare earth ecosystem. The story begins with an incredible natural endowment. China won the geological lottery. In northern China lies the Bayan mine in Inner Mongolia. Discovered originally in the 1920s as an iron ore deposit, it was later revealed to be the largest known rare earth deposit on the entire planet. It is a staggering expanse of mineral wealth. But the north only tells half the story. In the southern provinces, such as Guangxian, China holds vast reserves of what are called ion adsorption clays. These clays are incredibly special because they contain high concentrations of the heavier, incredibly valuable rare earths, elements like dysprosium and terbium, which are absolutely critical for making components that can withstand extremely high temperatures. But here is the catch about rare earths. Despite their name, they aren't actually that rare. You could probably find trace amounts of them in your own backyard. What is rare is finding them in concentrations high enough to mine economically. And more importantly, the true challenge lies in separating them from one another. Rare earth elements are chemically so similar to each other that separating them is notoriously difficult. Imagine trying to separate a drop of blue ink from a drop of purple ink once they've been mixed in a glass of water. For decades, the global standard for separating these elements relied on a process called fractional crystallization, which required repeating the same chemical steps thousands of times. It was tedious, slow, and incredibly expensive. This is where China's first major achievement happened. In the 1970s, a Chinese chemist named Guangxian, a man who is today widely revered as the father of Chinese rare earths, made a monumental scientific breakthrough. He and his team developed the cascade extraction theory. Instead of the old, low-yield separation methods, his team perfected a method using hundreds of sequential solvent extraction tanks. By precisely controlling the chemical baths step by step, balancing the exact acidity and flow rates, they could isolate specific rare earth elements with an unprecedented purity of over 99.99%. This was a watershed moment. China took this laboratory breakthrough and scaled it up to a massive industrial level that the world had never seen. They didn't just have the raw materials anymore. They now held the world's most efficient, cost-effective recipe for processing them. This scientific leap drastically lowered the global cost of highly purified rare earths, which in turn helped fuel the consumer electronics boom of the 1990s and 2000s. However, selling refined rare earth oxides, essentially highly purified powders, is a great business. But Chinese planners realized that true industrial development meant moving up the value chain. Why sell the flour when you can bake and sell the cake? To achieve this, China heavily funded specialized, targeted research. They built the Baotou Research Institute of Rare Earths, the largest dedicated research facility of its kind in the world. They established state key laboratories and trained thousands of metallurgists, chemists, and material scientists whose entire careers were specifically focused on these 17 elements. This immense brain trust allowed China to conquer the next massive hurdle: manufacturing neodymium iron boron, or NdFeB, permanent magnets. These are the most powerful permanent magnets on Earth. A piece the size of a coin can lift incredibly heavy weights, making them absolutely essential for the miniaturized high-torque motors in electric vehicles and the massive heavy-duty generators used in offshore wind turbines. Creating these magnets is an art form. It requires smelting the refined rare earths into metal alloys, milling them into a microscopic powder, pressing them under intense magnetic fields, and sintering them in high-temperature furnaces. China mastered every single step of this intricate process. By the 2000s, China had achieved something no other country had: a completely integrated end-to-end domestic supply chain. A raw rock could be pulled out of the ground in Inner Mongolia, chemically separated into pure oxides, smelted into metal ingots, alloyed and precision machined into a finished high-performance magnet without ever leaving the country. This incredible logistical efficiency drastically reduced manufacturing costs and accelerated production times to a level no competitor could match. As the industry grew to colossal proportions, China took decisive steps to optimize it and address the early growing pains. In the early days of the rare earth boom, the mining and refining processes were environmentally damaging, generating toxic wastewater. But as China moved into the modern era, the government orchestrated a massive industry consolidation. In late 2021, they merged several major state-owned producers into the China Rare Earth Group. This mega merger wasn't just an administrative reshuffling. It was a massive modernization and environmental cleanup effort. By consolidating the industry, Beijing could enforce much stricter environmental protections. They standardized high-tech manufacturing processes across the board and heavily invested in green mining technologies. Today, modern Chinese refineries utilize closed-loop systems that recycle wastewater and capture harmful emissions, drastically reducing the ecological footprint of extraction compared to the Wild West mining days of the 1980s. The result is a sector operating at a scale and sophistication that is simply difficult to comprehend. Today, China doesn't just lead in pulling rocks from the ground. They account for over 90% of the world's production of finished permanent magnets. Entire cities like Baotou in Inner Mongolia have completely transformed into rare earth megahubs. These are technological epicenters where global tech companies and automakers come directly to the source. In these industrial parks, the supply chain is so dense that a finished magnet can be driven just a few miles down the road to a factory where it is immediately installed into an electric vehicle motor. The story of China's rare earth industry is often misunderstood or oversimplified. It is not just a story of a country that happened to have a lot of a specific mineral within its borders. Natural resources only give you an opening. What China did was execute a masterclass in long-term industrial policy. It took decades of unwavering strategic vision, billions of dollars in specialized scientific research, and the sheer willpower to build an entire unassailable manufacturing ecosystem from the dirt up.